Welcome to BeeGraphy. In this tutorial, we'll create a customizable twisting tower showcasing the power of parametric design in our cloud-based platform. Learn how to create a dynamic, customizable twisting tower using parametric modeling in BeeGraphy. This tutorial demonstrates the power of node-based design, allowing you to easily control parameters like scale, twist angle, array count, and pipe radius for endless design variations. Perfect for architects, designers, and anyone interested in exploring computational design on the cloud. Let's start by adding two range input nodes. We'll call these Scale 1 and Scale 2. These will control the dimensions of our tower space. We'll set Scale 1 to 5 and Scale 2 to 15 for now, but we'll be able to adjust these later. Now let's add four construct point nodes. We'll use the Scale 1 and Scale 2 values to define the x and y coordinates of these points. We use opposite node, resulting in points being placed on the opposite sides of the x and y axes. With these 4 points, we will construct a curve that will form the base of the tower. With our 4 points defined, let's add an interpolate node. Connect the points to the point inputs on the interpolate node. This creates a smooth curve through our points. The Boolean toggle on the interpolate node is enabled, creating a closed curve. Next, we'll create an array of these curves along the z-axis. We'll use the linear array node, and we need a vector z to determine the direction. We can adjust the number of copies using a range input node for the count. We will set the size to 5 and name it distance. We will define the number of curves using a range input node, set the value to 30, and name it count. To give the tower a more elegant structure, we will use the rotate node. Connect the output from the linear array to the geometry input of the rotate node. We'll use a centroid node with the interpolate curve as input to define the center of rotation. We will define the rotation angle using a range input node, set the value to 360 degrees, and name it degree. We will convert the degrees to radians using the deg to rad node. Since the rotation of the curves must be sequential, we will use the list sequence SEC node, set the start to 0 and the end to the obtained radians. The count will be equal to the number of curves. With our rotated curves, we'll create a surface by using a loft surface node. Connect the rotated curves to the curve input. To make the tower more interesting, we will give thickness to the curves using the pipe node. We can also control the pipe radius with another range input node. We will name it pipe radius, set the minimum value to 0.1, the maximum value to 1, and the step to 0.1. Finally, let's add two apply material nodes to add color to the surface and the curves. The apply material node allows us to structure a realistic appearance by setting parameters such as color, metallicity, roughness, and opacity. We will move the variables to the left to make it easier. Thanks for watching. We hope this tutorial helped. For more on computational design, please like this video, subscribe to our channel, and hit the bell icon to get the notifications. See you in the next tutorial.